very intelligent beings, more intelligent than we are, that perished because of some catastrophe. A star exploded next to them.
The alarm does not sound in a control room, it hits when the image locks into focus. Scientists stare at the screen as the impossible becomes undeniable. The anti-tail of 3I Atlas is not flowing away from the sun like every comet ever recorded. It is pointing straight at it, against radiation pressure, against known physics, against expectation. For a brief moment, no one speaks because the geometry alone should not exist. Then the measurements arrive, and the silence breaks into disbelief. The structure stretches more than 500,000 kilometers, longer than the distance between Earth and the Moon. This is not a faint streamer or a temporary illusion. It is vast, rigid in direction, and sharply defined. No comet in human history, across centuries of observation, has produced an anti-tail anywhere near this scale. What should be fragile looks stable. What should disperse appears anchored. Within hours, observatories across the world halt scheduled work and pivot toward a single target. Raw data is pulled, recalibrated, and reprocessed again and again. Teams apply different filters, different wavelengths, different correction models, hoping to expose a mistake. Instead, each pass makes the situation worse. The anti-tail shows internal structure, directionality, coherence. Features that should be shredded instantly by solar forces are still intact. At this point, denial collapses. This is not a camera artifact, not a software glitch, not a trick of perspective. Independent instruments confirm the same geometry from different angles. The anti-tail is real, and it is behaving in a way that cometary material should not survive for more than minutes, yet it persists. As new frames stack, something even more unsettling becomes clear. The structure is not fading, it is growing. The anti-tail lengthens sunward as 3I Atlas dives deeper into the inner solar system, where radiation pressure should be strongest. Instead of being pushed back, material appears to be maintained, almost reinforced. The language in internal messages begins to change from unusual to unprecedented to unmodeled. One by one, trusted models begin to fail. Standard sublimation physics cannot explain the organization. Plasma interactions do not account for the scale. Dust dynamics break down entirely. Each rejected explanation tightens the pressure. This is no longer a rare comet doing something strange. This is an object violating assumptions that underpin how comets are understood at a fundamental level. And time is running out. 3I Atlas is moving fast, closing distance, entering regions where observation windows narrow and decisions become urgent. Whatever is happening now, not in theory, not in simulation. The anti-tail is already there, already massive, already defying explanation. As scientists scramble to understand how something like this could exist at all, a more dangerous question quietly emerges, one that shifts the focus from shape to motion. Because if the structure is this large, then the material forming it must be moving at speeds no one is ready to explain. And that calculation is about to change everything. The numbers hit like a shockwave. The moment velocity replaces size, the discovery turns from strange to dangerous. Calculations spread across screens in real time, and the silence inside observatories grows heavy. To build an anti-tail stretching more than 500,000 kilometers in just 45 days, material must be racing away from the nucleus at least 130 meters per second, and not away from the sun, but straight toward it. That single detail breaks expectation after expectation. Comet models were never built for this. Standard physics begins to buckle almost immediately. Sublimation, ice turning to gas under solar heat, cannot push dust sunward at this speed without tearing it apart. Solar radiation pressure should scatter the material into a wide, fading plume. The solar wind should shred it entirely. But none of that is happening. The anti-tail stays thin, tight, and sharply aligned, as if something is actively holding it together against forces that should destroy it. Inside research centers, the tone changes. Scientists stop using public language and start using internal words like instability and unaccounted acceleration. Motion plots refuse to smooth out. Error bars shrink instead of widening. The velocity does not decay the way passive material should. Instead, it stabilizes. Some datasets even hint at periodic reinforcement, brief moments where speed increases instead of fading. Emergency simulations begin running overnight across multiple institutions. Supercomputers churn through thousands of scenarios, adjusting dust size, gas composition, magnetic coupling, plasma drag. Each model fails in a different way. Some explode the tail, others bend it backward. None preserve its structure at this speed while pushing sunward. Confidence intervals collapse. What should be randomness keeps resolving into direction. Quiet admissions circulate through private channels. The motion does not behave like debris. It behaves like ejection, focused, sustained, and controlled. No one says the word out loud yet, but everyone feels it. Chaos would be comforting. Chaos would mean nature is still in charge. But what they are seeing is order where there should be none. By dawn, one conclusion is unavoidable. This is no longer a visual oddity or a measurement trick. The anti-tail is not just strange, it is doing something. Forces are acting. Energy is being maintained. The comet is no longer passively responding to the sun. And just as scientists begin asking what could drive motion like this, new data arrives, revealing that the structure isn't just moving fast, it's glowing. The alarm does not come from motion or size this time. It comes from color. When the December 14th 15 images load onto observatory screens, scientists immediately notice something that should not be there. The anti-tail of 3I Atlas is glowing, clearly, distinctly green-blue. Not faint, not patchy, stable, persistent. The room goes quiet as teams zoom in, recalibrate, and reprocess the data. The glow does not disappear, it intensifies. Spectral analysis begins within minutes, and the first results deepen the shock. The emission lines do not cleanly match known cometary gases, not cyanogen, not diatomic carbon, not sodium. The signatures overlap, but never fully align. Each comparison leaves residuals, unexplained energy where nothing should remain. This is not a textbook comet glow. Long exposure integrations are stacked to rule out error. Hours of data are combined. The color remains locked in place, uniform along the sunward structure. Noise is eliminated. Sensor artifacts are excluded. Independent instruments confirm the same wavelength range. At this point, equipment failure is no longer a credible explanation. What truly unsettles researchers is how the glow behaves. As the anti-tail stretches farther toward the sun, the emission grows stronger, not weaker. Under solar radiation pressure, dust and gas should disperse, fade, and lose coherence. Instead, the brightness increases with proximity to solar stress. This is the opposite of expected physics. It is backwards behavior. Teams begin running plasma interaction models. They compare the data against rare solar wind excitation events. They test charge exchange scenarios. They simulate ion tail interactions under extreme conditions. Every model falls short. None reproduce the stability, directionality, and sustained glow at this scale. The anti-tail does not look passive. The structure appears to be responding, engaging with the solar environment. Energy is being absorbed, redirected, or transformed in a controlled way. The glow suggests work is being done. Not reflected light, not random excitation, something closer to an active process. Quietly, a new concern spreads through the scientific channels. If energy transfer is occurring, then the anti-tail is not just material, it is a system that remains organized under forces that should tear it apart. This is no longer a discussion about how big or how fast the structure is. The question has shifted to why it is glowing at all. And as the data continues to stream in, researchers realize the next measurements may reveal something far more unsettling. Because if this glow changes, pulses, or synchronizes with solar activity, the implications will escalate immediately. The analysis is still running. And whatever this green-blue light truly represents, it may only be the beginning of what 3I Atlas is about to reveal next. The alarm does not come from the comet anymore. It comes from the limits of human vision. As 3I Atlas continues its silent passage, researchers confront a chilling realization. The systems designed to protect humanity are not built to see most of what moves through the solar system. Detection pipelines light up with activity, not because they are finding more objects, but because they are revealing how much they miss. Pan-STARRS, Atlas, and similar sky surveys scan night after night, yet their reach is brutally narrow. Anything smaller than roughly 100 meters fades into background noise. Anything moving too fast appears for only hours, sometimes minutes, before vanishing forever. Analysts admit that an object like 3I Atlas would have gone completely unnoticed if it were slightly smaller, slightly darker, or slightly faster. Simulation teams run retroactive models, feeding known survey limits into probability engines. The results are unsettling. For every interstellar object detected, dozens, possibly hundreds, could pass through the inner solar system unseen. No alerts, no names, no records, just silent transits through planetary space. The narrative shifts fast. 3I Atlas is no longer treated as a rare visitor. It becomes evidence, proof that detection does not equal frequency, only visibility. The question is no longer how strange is this object, but how many like it have already passed through. There is no census of interstellar traffic, no radar net, no early warning system for fast, dim, or non-reflective bodies. If a technological object were designed to minimize detection, small profile, high velocity, low albedo, it would move through the solar system like a ghost, invisible by design. Quiet conversations begin behind closed doors. Some researchers admit the truth out loud for the first time. Humanity has been watching the sky, but only a narrow slice of it. The rest remains dark, unmeasured, and unprotected. The realization lands hard. This was not discovery by preparedness, but by luck. 3I Atlas was not found because it is unique. It was found because it crossed a thin window of detectability. And if that window is this small, then something else follows inevitably. The fear is no longer about what 3I Atlas is, it is about what else has already passed through the solar system without leaving a trace. As scientists expand their models and widen their simulations, a new question begins to dominate every discussion, one that no instrument can yet answer. If this object slipped through so easily until now, what happens when the next one doesn't? The shift happens fast, and it is explosive. As natural explanations collapse one by one, a word enters the discussion that scientists had avoided saying out loud: propulsion. The anti-tail of 3I Atlas is no longer behaving like material being stripped away by heat. Its motion is sunward, sustained, and sharply confined, exactly the opposite of what erosion should produce. Velocity calculations show continuous output, not a single burst. This is not debris drifting. This is something pushing. When Avi Loeb publicly acknowledges that the data is consistent with a technological thruster, the reaction is immediate. Within minutes, research channels ignite, emergency meetings are scheduled, and observatories begin rechecking assumptions they thought were settled. Critics rush in, calling it speculation, but the numbers do not change. Every attempt to model the behavior using known comet physics fails under scrutiny. Radiation pressure cannot hold the structure together. Outgassing cannot maintain direction. Plasma effects cannot explain persistence. What remains is alignment, coherence, intent-like consistency. The hypothesis is not embraced, but it also cannot be ruled out. Physics, for the first time, refuses to close the door. And as the debate shifts from, is this possible, to, what if this is intentional? A more unsettling realization begins to spread quietly through the scientific community. If propulsion is even on the table, then the next question is no longer what 3I Atlas is, but why it is moving the way it is, and what it plans to do next. The alert comes in before dawn, flagged priority red across multiple observatories at once. 3I Atlas is nearing perigee faster than expected, and the remaining observation window is collapsing by the hour. Every missed frame now matters. Every second lost is data that will never be recovered. Ground-based telescopes pivot in near-continuous motion, tracking the object as it cuts through the inner solar system. Space-based instruments follow in parallel, stacking exposures in real time. The data stream becomes relentless. Raw images, spectra, velocity vectors, polarization maps, arriving faster than teams can fully analyze them. There is no pause. There is no reset. With each new image, the anti-tail refuses to weaken. Instead, it sharpens. Researchers expect fragmentation, dispersal, decay under solar stress. None of it happens. The structure remains narrow, aligned, and stable. Sunward. Against every established expectation, the more sunlight it absorbs, the more defined it appears. This is backwards, completely backwards. Behind closed doors, classification tables are quietly adjusted. Labels meant for rare comets are crossed out. Internal anomaly thresholds designed for once-in-a-century events are exceeded in silence. No announcement is made, no press release follows, but the internal language shifts. What was unusual becomes non-conforming. What was unlikely becomes unresolved. One researcher notes a chilling detail buried in the noise. The anti-tail's brightness fluctuates in short, irregular intervals, not random, not periodic, responsive, as if reacting to changes in the solar environment in real time. That single observation spreads through private channels like a shock wave. If the anti-tail grows any longer, models will break entirely. If it holds its shape past perigee, the remaining natural explanations collapse further. If it accelerates even slightly, the implications multiply instantly. At this stage, the scientific goal has inverted. No one is trying to prove an extraordinary origin anymore. The effort is now focused on eliminating it. Every hypothesis is tested with one question in mind. Can this still be natural? And with each failed test, the silence in the control rooms grows heavier. The object does not slow, it does not flare apart, it does not behave like debris. The realization settles in slowly, then all at once. This is not a past event being analyzed after the fact. This is happening now. The solar system is not studying a visitor, it is being traversed by one, watched, measured, interacted with, whether intentionally or not. And as the latest data packet finishes downloading, containing a subtle but undeniable shift in the anti-tail's orientation, teams pause, staring at screens that refuse to confirm what they are seeing. Because if that change is real, then the next phase is already beginning. And science may no longer be in control of the timeline.